Hi, hi guys. My name is Samuel Jasper. I'm from CSC department. My topic for database management systems for AIT is on optimization of connection-oriented mobile hybrid network systems. Introduction: modern communication networks are no longer simple or static. Today's system integrate connection-oriented communication, mobile users, hybrid network architecture to support applications such as mobile internet, cloud computing, IoT, and real-time services. Now, we live in a modern world where the technology is being evolving in a very rapid, fast way, and with the help of cables which are under the water, we are able to get the network from the internet service provider. Not only that, through this network, the communication takes place. The network uh, is being used by every single one on the ground. Not only that, this network which is being used by us through in this modern world are no longer simple or static. They integrate connection-oriented communication and mobile users and hybrid network architectures to support applications such as mobile internet, cloud computing, IoT, and real-time services. These networks face challenges like dynamic topologies changes, limited bandwidth, mobility management, and quality of services requirements. Yes, these networks, mobile hybrid network architectures such as mobile internet, cloud computing, real-time services face a lot of challenges such as dynamic topology, limited bandwidth, and mobility management, and there won't be any quality over the quantity on the internet they get. To address these issues, automation techniques are very essential to improve performance, reliability, scalability, and efficient source utilization. Optimization need to be done on every single program to ensure this time complexity and space complexity becomes lower and the cost efficient becomes lower and not only that the scaling takes place very fastly, the maintenance costs need to become slower. Optimization is a very uh, advanced tool which is used to simplify the problems and ensure the business runs in a very profitable manner, and also uh, there won't be any problems which are through this optimization technique. Connection oriented networks. Let's look into what connection oriented network systems is all about. It establishes a dedicated connection between data transmission begins. Data is transferred only after successful connection setup. Uh, let's say there is a person A, there is a person B, and data need to be transferred from person A to person C. So when person A, person B, person 3 are interconnected with a single network, only then the data is transferred from person A to person C. That is how connection-oriented network systems takes place. If there is no person B in between person A and person C, there won't be any data transmission. So it is very cost efficient. We cannot guarantee that there will always be a person B in order to send the data from person A to person C. It's very cost efficient and very reliable communication, order data delivery, error control, and flow control. Commonly used in applications requiring accuracy. For example, TCP, which has uh, which has 7 layers in order to transmit the data, asynchronous transfer mode, multi-protocol label switching, etc. Challenges in connection-oriented network. We face a lot of challenges in connection-oriented systems. One is connection setup delay, which increases initial communication time. Like I said, we need a person B in order to send a transmit, in order to send the data between person A and person C. Scalable issues. When many connections are established simultaneously, we cannot scale systems, and not only that is very cost efficient, and we cannot guarantee there will be a middle person in order to make a data transmission. and it becomes very complexity and congestion and clumsy uh, to handle the network. And not only that, congestion control complexity increases with heavy traffic. uh, it We cannot and also debugging the and also looking into the traffic. It takes a lot of time in order to make the pathway free. Inefficient bandwidth usage due to fixed resource reservation. Connection maintenance overhead in dynamic network environments. And the connection maintenance through this connection oriented network is very efficient and very overhead onto the head, which is in dynamic environments. Mobile network systems. Networks where nodes, which are devices or mobiles, can change locally and dynamically. Communications links can be wireless and network topology changes frequency. They hear wireless in the sense Wi-Fi, Hi-Fi, and etc. And we can mobile network systems can be done from topology like satellites and etc., which the frequency changes frequently. Key characteristics that we have are mobility of users devices, variable link quality, and limited bandwidth and energy constraints. For example, like in our mobile phones, we have cellular networks 4G and 5G, and mobile ad hoc networks, MANETs, which are very popular. Without them, there won't be any mobile network takes place. Challenges in mobile networks: frequent topology changes due to node mobility. So, like I said earlier, topology means the signals that we face from satellites. The frequency that we get from them are very frequently changing due to node mobility because they rotate around the sur- uh, around the Earth. So, like when they rotate, there won't be any regular frequency to our mobile network. So it changes very frequently. Handoffs and mobile mobility management can cause delays or dropout connections. Variable link quality leads to packet loss or retransmissions. Variable link quality in the sense, like when a person A sends a data to a person B, then person B sends to person C. Like when a person A sends to person B, the data is transferred into a packets. Those packets are transferred from B to person A to person B, and like when they move from person B to person C, the packets are merged into a single message, and the data is being forwarded to person C. This is what variable link quality is all about. Limited bandwidth affects throughput. So, like I said, limited bandwidth in the sense less cable or less fixed Mbps, Gbps. So it affects throughput, and there will be a lot of high latency, and throughput would be which affects it. And the energy power constraints on mobile devices are uh, very less because we need to charge our mobiles very regularly. Hybrid networks. It combines wired and wireless networks into single integrated systems. It supports both fixed and mobile nodes. It enables seamless communication across different network types. The key benefits that you have in hybrid network are it is flexibly connectable, efficient resource usage, scalability for diverse application. One of the examples that we can take is a SpaceX, which provides internet through hybrid. There won't be any uh, it takes network from directly from satellite. The network is transmitted from satellite to the person on the ground uh, any to anywhere, even if he is in the on water or any remote area. The network is being provided through the satellites. This is what hybrid networks is about. The examples: internet plus mobile devices, cloud edge computing networks. Why hybrid networks need optimization? Because uh, we have diverse traffic patterns, different latency and bandwidth requirements. It's and seamless integration of multiple technologies is challenging. So we need a hybrid network. So we need optimization. Optimization goal. The uh, ultimate goal we need to have is we need to minimize latency, which helps in real-time applications of video conferencing, online gaming, video streaming, and etc. Maximize throughput, ensuring high data rates imported in high traffic networks, and reduce packet loss, and improve energy efficiency. Conclusion. Modern networks are increasingly complex and heterogeneous, combining connection-oriented mobile and hybrid systems. Optimization is essential to improve performance, reliability, resource utilization, quality of services need to be met according to its needs, and it can be done only through the optimization. Techniques like adaptive routing, load balancing, traffic shaping plays a vital role. Future networks will increasingly rely on AI-driven optimization, SDN, and FD for better performance and seamless integration. Thank you.